In this video, we're going to continue to talk about alternating series error bound. Let's say we have f of x is represented by this power series. And notice this is an alternating series. Let p sub 4 of x be the fourth degree Taylor polynomial for f about x equals 0. That means the center is at 0. Use the alternating series error bound to find an upper bound for absolute value of p sub 4 of 2 minus f of 2. Since they are asking us to use the alternating series error bound, we already know that this is a convergent alternating series. And we know that f of 2 will be, instead of x, plug in 2, you get these terms. Now, what is p sub 4 of 2? P sub 4 of x is a 4th degree Taylor polynomial, which means p sub 4 of 2 will be represented by these three terms. Now, what is the first unused term? First unused term will be this right here. So to find the maximum error is going to be absolute value of negative 2 to the 5th power over 4 times 3 to the 4. And when you simplify this, you get 8 over 81. So p sub 4 of 2 will be the approximate value of actual value of f of 2. And the error, when you approximate the error, the maximum error will be 8 over 81. We have g of x equals to this power series over here. And let p sub n of 1 over 2 represent the nth degree Taylor polynomial for g about x equals 0, evaluated x equals 1 over 2. Use the alternating error bound to show that the error is less than 1 over 500 when x equals 1 over 2. We know that g of 1 over 2 equals, instead of x, you got to plug in 1 over 2. So you get these terms. And what about p sub 4 of 1 over 2? Well, that is a 4th degree, so that will be these three terms over here. And this is the first unused term. That means the error will be less than the absolute value of negative quantity 1 over 2 to the 5th power over 20. Now we have to show that this is less than 1 over 500 though. So what is this value? When you simplify this, you get 1 over 32 times 20. And you know that that is less than 1 over 500. So we just show that the error bound of this will be less than 1 over 500. Now we have f of x equals this power series right here. Part A says the Taylor series for f about x equals 1. Now the center is at 1, can be used to represent f of 1.2 as an alternating series. Use the first three non-zero terms of the alternating series to approximate actual value of f of 1.2. So first three non-zero terms are these three right here. And notice the degree is 2, so this is like p of 2 of 1.2 is 1 minus 1 over 2 times 1.2 minus 1 plus 1 over 2 squared times 2 times the quantity 1.2 minus 1 squared. So this will be the approximation of the actual value of f of 1.2. After you simplify this, you get 1 minus 0.1 plus 0.005, which is equal to 0.905. So this is the approximation of f of 1.2. Now for part B, we need to show that the approximation found in part A is within 0.001 of the exact value of f of 1.2. And we know that f of 1.2 is 1 minus 1 over 2 times 0.2 plus 1 over 2 squared times 2 times 0.2 squared and so forth. And we found in part A that approximation p sub 2 of 1.2 is 0.905. So we used these three terms to find p sub 2, the approximation of f of 1.2. Now, to find the maximum error, first unused term is this right here. This will be the first neglected term. Therefore, the maximum error is at most is less than or equal to the absolute value of this. And when you simplify this, you get 1 over 3,000. And you know that 1 over 3,000 is less than 0.001. So therefore, the maximum error, the approximation, is within 0.001 of the exact value of f of 1.2.